Hello, my name is Mia Gomez, and this is my Lab 4 over Oscillations for Physics 1. Within this lab, our purpose was to compare the predicted and observed motion of the mass connected to its oscillating spring with consideration of the energy principle. And we were just trying to make some graphs to analyze the motion and the energy. And then our findings were that the graphs for the model and experimental data and the x position were very similar, and they were almost exactly lined up. But in terms of the y position, they varied. And there was a big difference, which we'll see later on. And this was more than likely just due to program errors and lack of consideration for some additional factors. The kinetic gravitational potential and spring potential energy oscillate with the motion of the spring, yet the total energy remained constantly zero as an effect of the energy principle. Key concepts within this lab are, of course, Newton's second law, as that allowed us to have knowledge for the velocity update formula and therefore the position update formula. Since we could take our initial velocity, add that to our net force, divide by our mass, times our change in time. And then with that, we would take the final velocity we had just found and put that in the position update formula, as we would take the initial position plus the average velocity times the change in time. And because it is a non-constant force, the average velocity is just the final velocity of the prior one. Spring force was used in terms of F net. And then another major part of this lab was the energy principle, as change in energy of the system equals work surrounding plus the heat. But for this lab, the change in energy of the system is just zero because work surrounding and heat add to zero. But within change in energy of the system, we have kinetic energy, which is 1/2 mv squared, gravitational potential energy, which is the mass position relevant to the Earth. So that's just mass times gravity times its y value, its change in height, its height. And then we had spring potential energy, which is its potential in relation to the spring. So 1/2 times the spring constant times s squared. Here's a free body diagram. We have an upward force, which is the spring force, and then we have a force going downward, and that's force gravity. And the F net is just zero. That cancels out because it's constant. Well, it's a constant net force of zero. And then within that, we have spring force and force gravity. And then the change in energy of the system is zero. But within the change in energy, as I said before, we have kinetic, gravitational potential, and spring potential. The system is the Earth, the spring, and the mass. And the surroundings is everything else. So here is the video that was analyzed with the tracker data. You can see all the different points pointed on the approximate center of mass of the spring, and you can see how the motion oscillates. So that was observed. And then here is the code I wrote. So on the left-hand side, we have the initializations. So we have the spring constant, Rex length of spring, and then that was allowed us to find the energy using the formulas that I had stated earlier, because we found kinetic, gravitational potential, and spring potential, which allowed us to find total energy. And on the right-hand side, this was when we were in the loop. And so we were able to make a graph thus with that knowledge, because we had knowledge of all the forces, which we found in the top half, applied the momentum principle, the velocity and position update formula, and then we found our energy. So this allowed us to make the graphs. So here's our graphs. On the left-hand side, we have the change in energy. So note that the general shape of the gravitational potential energy and the kinetic, and then also the spring. That one's a little more varied, but especially important to note on this slide is the orange line, as that is the change in energy and how it remained relatively zero throughout the lab. And then for the X position, um, that stayed model and experiment were very close, but for the Y position, they varied. And then in conclusion, the change in energy is zero, but the kinetic and gravitational potential energy oscillate in opposing directions, and spring potential energy has a less smooth curve. The model is accurate predicting the X position throughout the cycle of motion, but not as accurate for the Y position, because but it was still able to find a general trend for increasing and decreasing Y position. And some potential sources of error for this could be inaccurate identification of center of mass position in tracker, and then the model assumes no other outside forces than the ones being analyzed. So those could have had a dramatic effect on the Y position. Further questions in this model, is the energy principle satisfied? And this is yes. As seen in the change in energy versus time graphs, the sum of the different energies equals the total energy at zero. And that's exactly what the energy principle is. And then we also made estimations of the oscillation periods by estimating the period of oscillations for the x position and the y position data. And this was just made by observing the individual position graphs. And so for the x position oscillation time, it was 1.71 seconds. For the y, it was 1.52. And this is a 0.19 second difference. So they are not in sync, which is a little strange, but it does make sense. All right, thank you very much.